My name's Linnell Wiley, and I'm a biology teacher. Science in education is very important and becoming more and more important every year. There's this critical choice when you finish undergrad. Do you want to go into industry and science or not? You've been prepping for this science-based career your whole undergrad, and oftentimes the reality of science jobs is not as glamorous as you might think. We might love science, but the idea of spending all day in a lab may be terrifying to some and very gratifying to others. In my experience in industry, that was really difficult for me, being isolated in a lab, and I found that I really needed a different kind of career to fit my personality. I love science, and I love being able to test out new ways of teaching with my students. I love being able to collect data on their performance and track their results on their assessments and see how what I'm doing is affecting that and continually changing what I'm doing to improve myself. And it's never boring. I mean, how many jobs can you say that you just wish you had more time to do your job? And that's the thing I love about teaching. I never once look at the clock except to be surprised that the period is over.
Yeah.
Well, no, look at your plate. So plate 2, the bacteria on plate 2 are more resistant to which antibiotic?
E, B, and C.
When I said more, though, are they the same for one of them?
Oh, I don't know. They D?
They're the same for D.
Oh yeah, they are. Yeah.
But you're right. So E and D and C have lots of growth here, but in terms of comparison,
Yeah.
yeah, E and C are more affected. Yeah, on plate 1. So are we on our EXT here?
Yeah.
So what are our groups?
N, K, T, A, and T, E.
Okay, what are those things?
These are the antibiotics.
Antibiotics.
Yeah.
So when you talk about the difference between the groups, that's our what?
Independent variable.
So what is the difference between the groups?
They're different types of.
Okay. And then what are we? So what do you have listed as your IV?
Area of inhibition.
Okay.
Inhibition.
There you go. So what are we measuring?
The area. Oh, so it'll be the antibiotic, then the area.
So the antibiotic would be the IV.
So the IV is the difference between your groups. It's the independent variable. It's the thing that we set up to be different before we measured anything. What did we set up that was different here between the groups?
Antibiotics.
And then what did we measure? What was our DV?
The E. coli. The effect on the E. coli.
How did we measure the effect on the E. coli?
You should. If.
Ms. Wiley, do you have some?
Hold on. How are we measuring the effect on the E. coli? What are we going to measure? Did you go back to this?
Oh, the area of inhibition.
Okay. So that's why it's set up with these first.
Yeah.
So you have some idea what you're measuring. What was your question, Sonny?
Do you have some kid-friendly antibiotics?
Some kid-friendly? I don't have any with me, no.
Oh, yeah. I'm meaning like
Yes.
cough drops or something.
So, for number 2, you just measure them, right? Or do you have to, find the actual, area?
Oh, no, just measure, because we're just measuring what part of that circle.
So this is... Right.
Does that say centimeters or millimeters, though?
Millimeters.
Oh,
Sorry.
just making sure. So
And
let's...
then number
Yeah.
1,
Uh-huh.
I don't understand.
Well, let's see. What's it asking?
It's asking if the 2 strands are different of DNA.
No, we're talking about strands of DNA or strains of bacteria. So what is a strain? What does that mean?
Like a different type of bacteria.
That's exactly right. So what's different between plate 1 and plate 2?
Plate 1 is E. coli, and then plate 2 is staph.
So those are 2 different types of bacteria. So what is the same between those 2 plates?
They both have like a zone of inhibition.
They do around the same antibiotics?
No.
Oh, okay. So did we use the same antibiotics on...
The 2 plates?
Mm-hmm.
Yeah.
Okay. So then that's the same antibiotics.
Mm-hmm.
What's different?
Where the zone of inhibition is.
Mm-hmm. Which antibiotic is the most effective for plate 1?
C.
What was the... And then how does that compare to plate 2?
Because C had, like, nothing. Or, like, it wasn't effective.
Mm-hmm. So when you ask that question, according to the data, does the same antibiotics affect the strains equally?
Oh, no.
And how
Okay.
can you tell?
Oh, okay. That makes more sense because I didn't know, like, what the letters...
So let's clarify. What do those letters mean?
The antibiotics.
Mm-hmm. And what do the plates mean?
The 2 different strands of DNA, right?
We're talking about strands of DNA?
Strains.
Say, strains of what? There you go.
Or bacteria, it's not DNA.
Right. Well, they have DNA. So you're not totally wrong. The strains of bacteria, different strains do have different strands. How are we doing?
Okay.
Do you have any questions?
No, I'm reading the last one.
Okay.
Also, wait, not one question. Do we use inches or do we use centimeters?
Let's use millimeters, so let's not use that ruler. We got to get a ruler. There's rulers in the back that have centimeters.
Millimeters.
Thanks. How are we doing? What did I say? What is an IV? The what? The independent variable? It's the difference between what?
The antibiotics on the bacteria and the active inhibition around.
So that's what we've... So always remember, the difference between these groups is what your independent variable is. Because we've set these groups up to be different. Before we even collected data, we set something up to test. So this is what we're testing. So we're not testing the area of inhibition.
Yeah, I was gonna erase that.
Okay.
But I'm just working my way down.
Yes. Mm-hmm. Yeah?
Yeah, so I got like the title, I guess. Wouldn't it be the effect of the different antibiotics on the E. coli growth?
Mm-hmm. Are we measuring the growth?
Well,
Checking if it's
I mean,
colonies
Uh-huh,
or lawns, right?
Mm-hmm. And then we're also measuring something.
it's the resistance to the antibiotics.
So that's why this is... What did we measure? What are we measuring here?
The areas of inhibition.
Okay, so we're going to measure that, but we're also looking at growth and colony. So you're right. We're measuring two
Yeah.
different things, right?
Yeah.
Okay. So make sure that what we're measuring is your dependent variable.
Alright.
Okay.
Alright.
And then what are the things we kept the same?
The
for-
constants. So
Uh-huh.
the food or the broth. I don't remember exactly what it's called, but the broth stuff
Mm-hmm.
is going to be the same. And then I also got the bacteria because it's all E. coli's bacteria, and they all have like the same amount of space inside the petri dish to grow.
Mm-hmm.
And then they all were incubated for the same amount of time, so the reproduction rate is going to be
Yeah.
same too.
Yeah, you guys got that. All right. Do you have the questions answered?
Yeah.
Okay. So go ahead and get your plate out of the incubator. Yep.
Is it about the effect of antibiotics on the bacteria?
Yeah, it is. So let's fill in your EXD. Remember to start in the middle. I always start with the groups. So what groups do you have? How could we describe the groups that we have?
The groups are the antibiotics, and the number of trials are the just the bacteria itself. So there's just one trial for each.
How many times did we test the effect of each antibiotic?
Once.
One time. So that would be, that's
One.
our trial. So what is the thing that we set up to be different? What are we testing? Our independent variable is what we're testing.
The independent variable is the antibiotics.
Mm-hmm.
The dependent variable is bacteria.
Yeah, what about the bacteria? Be specific.
It's the same. Nothing changed about it.
Okay, so then what are we measuring? What data are we collecting for your DV?
No, the bacteria was the DV. The IV is the antibiotic. The DV is the bacteria.
So you're right, you're close. What is it about the bacteria that we're going to measure?
the area of inhibility.
Yeah, close. We call it inhibition, the zone of inhibition.
Why do I think inhibility? I don't know
Well,
why.
it's the same word, right? Inability, inhibition. It means to stop something. So it's their inability to grow in that area. We call it the zone of inhibition, but it doesn't. It's the space where what's not happening.
It's a space where there's no bacteria.
You got it. That's all right. You don't need the word. You just need to know what it is. Yes, sir.
Would one of the constants be amount of bacteria? Could that be a constant?
Tell me why.
Because there's throughout all the plate or through this different section of the plate, there could be the same amount of bacteria because we spread it out.
Mm-hmm. Yeah, that's why we spread it evenly. That was the goal. Absolutely, I think that's a good one. Mm-hmm.
On the IV on the hypothesis, is it IV on DV
Uh-huh.
for hypothesis?
Yep, that's the format for hypothesis.
Wait. So would so one dependent variable is the thing that doesn't change, right? Or is it the?
So what is that word variable? They're both changing. So you're thinking of what is the thing that's the same between the groups?
Oh, that's constant.
Yes.
I forgot what's the. I remember what dependent and independent variable meant, but I did remember, but I forgot.
So the independent variable is the thing we're testing. We're testing, the effect of what?
Like the bacteria. Not the effect of antibiotics.
Mm-hmm. And then what the dependent is what we're measuring. What are we going to measure?
The inhibition.
Mm-hmm. Get that written down so you don't forget. How are we doing, Haley? So what is different between plate 1 and plate 2? Mm-hmm.
Well, A has a zone of inhibition.
Mm-hmm.
A over here does it. And C, the same thing.
So what do A, B, C, D, and E represent?
Coli.
So these are all E. coli?
Or bacteria? No, antibiotics, right? No? I don't know.
What do you think? Think about it.
Well, I would think different antibiotics.
Mm-hmm. Are the antibiotics the same on both plates?
Mm-hmm.
Mm-hmm. Do they have the same effect on both plates?
No.
Oh, so then what's different between plate 1 and 2?
I guess they have different things on them.
What do you mean by things?
Different, the Jello stuff or whatever.
Oh, okay. So what's on the? So the Jello is just the food.
Mm-hmm.
What did it say? Here, let's read this again. Plate 1 and 2 contain the same antibiotics, but different strains of bacteria.
Oh, so it has different strains of bacteria on each plate.
What does that mean? What's a strain of bacteria?
It has different genes and
Mm-hmm.
different mutations and all that.
Mm-hmm. So they actually name them. E. coli is on one plate, and this other one, staph, is on the other plate. So the bacteria on this plate is different from the bacteria on this. So let's call this one E. coli. Which antibiotic worked best for E. coli?
C.
Prove it to me. Tell me why you think that.
Because the zone of inhibition is bigger, which means the antibiotics spread more.
It spread the same on both. What did it do differently on
Killed
plate
them.
1? And what did it not do on plate 2?
On plate 1, it killed the bacteria, and on plate 2, it didn't kill as much.
Awesome. Okay, do you have any questions?
Yeah, about the effect of, so it would be the effect of bacteria on E. coli?
So let's remember, it's the effect of IV on DV, but let's go down here and figure out what our IV and our DV is first.
IV would be the bacteria.
So I always think of the IV as the difference between my groups. So what are my groups here? I always fill that one in first.
They're the antibiotics.
Mm-hmm. And then your DV is what you're measuring. So what are we actually measuring here? What did we measure on that first page?
We measure the zone of inhibition.
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 Yeah. So that's what we're measuring.
So this would be a zone of inhibition.
Mm-hmm. Good. All right, once you are done with your EXD and some of you are getting close, you can go ahead and get your plate from the incubator and start collecting some data.
Yeah, so this one, basically, like, it didn't affect the reaction stage. What is this?
How are we measuring?
Like, this one, like,
We're actually measuring.
yeah, like, this one here, or plate one, bigger than
Inhibit. Good. How are we doing? Questions? You're working with this group? Okay, let's get that going. Do you guys hear us? I'll make that.
The effect of, what was it?
The antibodies on plus 1 and 2.
No, the effect on bacteria by antibiotics.
On the effects of antibiotics on bacteria.
So remember, we don't start necessarily with the title. Because in order to do your title, you have to kind of have identified your independent and your dependent. So what is your independent variable? So what is an independent variable?
Something that doesn't change.
It changes.
So a variable, if I vary my hairstyle every day, what am I doing to it?
Changes.
So both of those are variables. So what's the difference then between your independent and your dependent?
Dependent relies on.
The dependent relies on the independent. So the independent variable is what we're testing. We're testing the effect of the independent variable.
So we're testing the effect of antibiotics. So the dependent's bacteria.
So what do you mean by that?
You mean like the E. coli one?
Yeah, the E. coli.
What about it?
Like how it's going to change from
Or like, does it survive or die? Like,
How do we measure that?
with the milliliters.
Oh, so.
Oh, we measure it by the zone of, yeah.
Okay, so we're going to measure the what?
The zone.
The stopping zone, right?
Yeah, what is it called? It's a stopping, that's exactly what it is. The zone of inhibition. It's a tricky one. Inhibition. So then what are you going to keep the same? So you got bacteria that are exposed to all of your antibiotics. What's going to be this? And we know the antibiotic is different. And we know the zone might be different. What's going to be the same between those?
The time it's in the incubator.
Good. Faith, you give me one now.
The amount
of
the what's it called? The antibiotic.
Oh, damn it. I was
good.
gonna say that one.
I think that's good. There's lots in this experiment. Sound it out. In Q, like cube.
There's E in it?
No.
Okay.
Just CUB ator.
It's yours, Jose.
The constant. The plate.
What do you mean by that? There's lots about the plate.
Was that jello stuff in there?
We call it auger, nutrient auger.
Nutrient auger.
So like what is nutrient auger? What is that?
They all eat the same food.
Yeah, same type of food. Good.